It began like any other Tuesday. The world turned, people went about their lives, coffee was brewed, commutes were made. But then, a notification buzzed across the globe. A simple yet world-shattering headline from NASA. The kind of news you read twice, then a third time just to be sure. The space agency had called an emergency press conference. Speculation ran wild for a few frantic hours. Had a new planet been found? Was there a major solar flare? The truth, when it came, was far more profound. It was a moment that split history into two distinct eras, before we knew, and after. At a podium, under the glare of 1,000 cameras, the NASA administrator stepped forward. The room fell silent. The entire planet held its collective breath. With a voice that was steady yet heavy with the weight of the words to come, the announcement was made. We are not alone. It was a simple phrase, 4 small words. But they landed with the force of an asteroid impact, reshaping our understanding. The evidence was unequivocal. The data had been checked, double-checked, and triple-checked by teams around the world. Life, not ancient fossils, not the chemical precursors to life, but living, breathing organisms had been confirmed on the planet Mars. Imagine that moment. So, what is this world that now hosts a second story of life? What is Mars really like? For centuries we saw it as a wandering red star in the night, a god of war. Our imagination ran wild, but our robotic explorers have painted a much clearer, more fantastic picture. Mars is a world of breathtaking extremes. Olympus Mons, the largest volcano in the solar system, stands nearly 3 times the height of Mount Everest. It's so wide that from its base the peak would be beyond the horizon, large enough to cover Arizona. Valles Marineris stretches the width of the United States, a titanic scar that dwarfs our Grand Canyon. The surface is a global frozen desert. Its ruddy hue comes from iron oxide, rust. The entire planet is, in a sense, rusting away. Fine red dust covers everything, whipped into planet-encircling storms for weeks. Ancient craters, vast plains, and slow-marching dunes define the terrain. Amidst this desolation, signs of a different past. Dry riverbeds, ancient deltas, and water-formed minerals tell a clear story. Mars was once wet. Perseverance landed in Jezero Crater, an ancient lake fed by a river delta. It now roves atop lakebed sediments billions of years old. Mars had the right ingredients: water, organic molecules, energy, then lost them all. Or so we thought. To understand how life could exist there today, start with the sky. A pale butterscotch pink. The air is thin, over 100 times less dense than Earth's. Pressure so low your blood would boil without a suit. Little protection from harsh radiation. Heat escapes, temperatures swing wildly. Equatorial days can reach 20 degrees Celsius, yet nights plunge to minus 73 degrees Celsius. Winds sculpt dunes, towering dust devils dance, storms can block out the sun for months. Water once carved canyons and filled craters. Where did it go? Much is locked as ice in polar caps, water and dry ice, and buried permafrost. MRO radar hints at underground glaciers. Liquid at the surface today would boil away, hostile to life. The search turned underground, shielded from radiation and cold. We had to look down. The story of this discovery is a human story, but carried out by our extraordinary robotic children. For over 50 years we've sent probes, landers, and rovers to the Red Planet, each building on the last. Spirit and Opportunity roamed for years, proving persistent liquid water once flowed. Curiosity, a car-sized lab, landed in Gale in 2012, drilling, zapping rocks, confirming key ingredients for life in an ancient lake bed. Perseverance arrived with astrobiology at its core: Sherlock, Watson, Pixel, hunting organics and watery altered minerals, with Ingenuity scouting from above. The trail began along the ancient river delta, rich in clays and carbonates, rocks that on Earth preserve life's traces. RimFacts mapped layers up to 10 meters below, sending radio waves and listening for echoes. Visual RimFacts revealed an anomalous pocket about 5 meters down, signals consistent with ice and slushy, salt-rich brine, liquid at Martian cold. The team redirected. The rover drilled carefully above the anomaly, sampling and analyzing as it bored. Sensors flagged a sudden methane spike, then a complex isotopic mix that on Earth is almost exclusively biological: the smoking gun. Finally, the core revealed its secret under a microscopic imager. Within the icy brine, tiny filaments. They moved, slowly, unmistakably, autonomous motion. Not crystals, not mineral growth, organisms. Life, confirmed, 5 meters beneath the Martian soil. Shock gave way to awe. Telescopes swung to the red dot. Our neighbor was no longer barren, it was alive. And with that, a new age of cosmic discovery truly began. What is this life? A first look. Initial analyses offer a tantalizing glimpse. Microscopic organisms resembling Earth's extremophiles, from boiling springs to abyssal vents, Antarctic deserts to salty lakes, life, once started, is tenacious. These appear to be chemoautotrophs, rock-eaters, deriving energy from chemical reactions in mineral-rich brines, sheltered underground from radiation and cold. Are they a second genesis, or cousins? Early Earth and Mars were alike. Impacts can trade rocks, a pathway called panspermia. Do they use DNA, RNA, or something else? Rover labs detect complex organics but can't fully sequence. We need samples on Earth. Mars sample return. NASA and ESA, now the most important mission in history. Are we truly alone? For our entire existence, we've been an audience of one. We looked into a silent cosmos, our pale blue dot the only known stage. This discovery changes the script. Finding life here, in our own system, has staggering implications. We now have a data set of 2. Among 8 planets, life arose on at least 2. Kepler showed most stars host planets, many rocky, Earth-sized, inhabitable zones, billions of potential homes. Mars is proof of concept. If life takes hold on a cold, irradiated desert, what of Europa's and Enceladus's vast warm oceans? The search accelerates. Bigger telescopes, spectra of distant skies, SETI in the mainstream. A new chapter for humanity. This is more than a scientific breakthrough. It is cultural, philosophical, spiritual, reshaping how we see ourselves. It asks us to zoom out. We are Earthlings, representatives of life on one of 2 known living worlds. This shared identity can unify us and reminds us to protect our cradle and explore wisely. Artists, philosophers, theologians, and teachers will all carry this forward. Next, bring samples home. Launch from another world, rendezvous in orbit, return to Earth and study them in our most advanced labs. Human astrobiologists on Mars will follow. We are the generation that learned we are not alone. The universe is waiting.